So the region in the first quadrant, if we look at this, y equals x squared, we've got our parabola, the vertex at 0. X equals 0 is just the y-axis, and then y equals 4. So it really kind of breaks up into two different regions here. I forgot to put this in the direction, so that's why I told you it should be in the first quadrant here. So this region is what we're looking at. And looking at that region, if we're finding area, we could use dx or dy cut. It would work either way. But we're trying to find the volume when it's revolved around the line x equals 3. So what kind of cut are we going to have here? dx, right? Because for this, you guys are messing me up. That's what I get for listening to you. No, not a dx cut. It's going to be a dy cut. So this is a vertical line, so it's like a vertical axis, like the y-axis. If it were the y-axis, we do a dy cut. If we have a vertical line that we're going across, also a dy cut. Another way to look at it is that the rectangle should always be perpendicular to that axis of revolution for discs and washers. Right? So the rectangle is perpendicular to the axis of revolution. So if we look at this, our little radius goes from the axis of revolution to the closest function. Big radius, axis of revolution to the furthest function. So our little radius, now we're doing this horizontally. Right? Horizontal distance, we have to do right minus left. So for our little radius, what's on the right side? The axis of revolution or the parabola? Axis of revolution, right? So we're doing the axis of revolution minus the parabola. Since this is a dy cut, everything we're putting in here has to be in terms of y. So for our radius, little radius, I'm sorry, the axis, what's the axis going to be? 3. Right, so our little radius is going to be 3 minus parabola. We have to write what that x value of the parabola is in terms of y. So if we look at our equation, what would x be equal to? Not just square root of y. You were right, but you're not 100% right. We get plus or minus. So technically, in this case, we're only looking at this half of the parabola, which is the positive square root of y. So you're right. But I just wanted to point out, sometimes, if we were doing the part in the second quadrant, we'd have to use the negative square root of y in our problem. Does that make sense? Right, if we're using that left half of the graph, we would use the negative square root of y. So our little radius is 3 minus square root of y. Big radius, again, we're doing right minus left. So the right side is the axis of revolution, minus the left side is just what? 0, right? The y-axis. So we get 3 minus 0, or just 3. Once we have our two radii, we can set this up. Pi times definite integral. What's our smallest x value? 0. Biggest x value, we have to figure out where these intersect. Right, where the parabola intersects with the line y equals 4. So put 4 in for y. Just use substitution. So x could be positive or negative 2. Well, obviously this one's going to be positive 2. So our biggest x value is 2. Big radius is 3, so we have 3 squared minus little radius, 3 minus square root of y squared dy.